This video is going to quickly review 3 topics in Chapter 6. The first one is finding the inverse equation. So there are 4 steps to follow. My function here is f of x equals 3x minus 5. Step 1 is to replace the f of x notation with a y. Step 2 is going to switch x and y's places. Step 3, you need to solve the equation for y. So in this case, we're going to add 5 and then divide by 3. And lastly, you need to replace the y with the f inverse notation, so that f of negative 1 of x. So this would be your final inverse equation. Now, if you get to the bottom and you can simplify anything, please go a step further, but 5/3 you can't reduce, and you can leave it as x over 3 or 1/3 x. The next topic you need to know is function operations. So sometimes you will have to add 2 functions or subtract them. In that case, you're going to just combine like terms. The one I'm going to show you is where to multiply 2 functions. So you're going to have 2 functions. Let's say one is f of x, and that's x squared plus 3. And another is g of x, and that is 4x minus 1. And they want you to multiply f of x and g of x together. So you could do the box method here. You could FOIL, whatever you're most comfortable with. I'm going to show the box method. So this is x squared and 3, 4x minus 1. We're going to fill in the center of the box. So this is going to be 4x times x squared is 4x cubed. 4x times 3 is 12x. Negative 1 times x squared is negative x squared. And negative 1 times 3 is negative 3. So when you write your final answer, it should be written in standard form, meaning the highest exponent comes first. So this is going to be 4x cubed minus the x squared term next, plus the 12x, and then minus the constant at the end, so minus 3. So that is your final answer to that one. And the last topic is simplifying radicals. So you can make a factor tree or some side work. So I'm going to do 2 examples. The first one is 7 times the square root of 150. So I'm going to go off to the side and do a factor tree for 150. Break that down into 15 times 10. 15 is a 3 and a 5. 10 is a 5 and a 2. So I could rewrite this as 7 times the square root of 2 times 3 times 5 times 5. And we should know that 5 times 5 under there is kind of the same as saying the square root of 25, which is a 5. So that pair is going to come out front and join the 7. So this is going to be 7 times 5, and the 2 times 3 stay underneath. So then the outside numbers multiply together to 35, and the underneath numbers is the square root of 6. So one more like this. What if it was negative 4 times the square root of 50? So some of you can automatically look at 50 and know there's a perfect square root in it. You could break this down into the square root of 25 times the square root of 2. And you know the square root of 25 is 5. So that is 5 root 2. So you have the negative 4 in the front. And then if you change the square root of 50 into 5 times the square root of 2, it's going to look like this. And you have to put the outside numbers together, so that is negative 20 times the square root of 2.